Very good morning, everyone. Today we are going to take a look on the mitigation of methane emission from rice field, which is an emerging issue and relates with the climate, in which we are going to cover the introductory part, how the methane gas produces and how it is responsible for the climate change, mechanisms for the methane formation and its mitigation. There are several mitigation options which we are going to cover in this topic, and on the basis of several case studies we are going to conclude some points and some future perspective what we have to do in our friends. We all know that the methane is saturated hydrocarbon with chemical formula of CH4, and which is having a potential as 28 times more than the carbon dioxide for heating capacity. It was discovered by the Alessandro Volta in 1777. It is also known as the Mars gas because it is obtained or produced from the wetlands. Methane is an important gas that contributes global warming. As I told you that the 28 times more global warming potential than the carbon dioxide. It can be used as we know, the contribution of the methane is in global warming is 16%. But the figure says that this carbon dioxide and carbon monoxide 65% is responsible. But as we consider the potential of this methane, it moves more than its carbon dioxide. But carbon dioxide can be utilized by the plants and some animals also, but methane gas would not. That's why it's an issue. The sources of methane emission, here we can see clearly that the anthropogenic source 63%, of which the paddy field, only specific the crop is given, the paddy field, which is grown under the submergence, it is 10%. And sometimes the fossil fuels, ruminants, biomass burning, landfills and waste treatments, all these are responsible for gas. This figure clearly shows that it doesn't need any kind of the explanation, because in 1980s the emission is near about 1600, but now in 2020s it is near about 2000. 1600 to 2000, big gap is covered in between these 20 to 40 years. This graphical figure shows that in 1985 the methane emission is more, but onwards it is declining. It is because of the green revolution. When in green revolution the promotion to the chemical fertilizers was there, organic matter addition was reduced. Because of that, when the organic matter addition reduced, it automatically reduces the emission of the carbon dioxide as well as the methane gases, and that's why the methane emission is in declining rate up to the 2005. Afterwards, the promotion towards the organic farming was there. That's why the addition of organic matter was there, and that's why the emission increased, and now it leads up to the 2000 ppb. Mechanism for the methane formation, and it's this methane cycle we can observe here. The carbon dioxide is responsible for photosynthesis. Without carbon dioxide, the plant cannot perform the photosynthesis process, and photosynthesis process is a most important phenomenon in this universe, without which we cannot live. Any living being cannot live. Photosynthesis leads to the organic matter. When organic matter observed or it fall in the soil surface, it get decomposed by two ways, aerobic and anaerobic. If it get decomposed with the aerobic, then it forms again CO2 and water molecule. But when it decomposes anaerobically, it forms methane gas. Obviously, this anaerobic process occurs from the hydrolysis, then syntropy, fermentation and acetogenesis. These three processes get run through and acetate forms. When that acetate comes in contact with the methanogens, that methanogens leads to the process of methanogenesis, and which forms methane gas. That methane gas, if the methanotropes are available there, then get trapped with that methanotrophs, otherwise it will get escaped to the atmosphere. And that methanotrophs feeds on the methane gas and it forms the CO2 gas, which is escaped. Methanogenesis performed by the methanogens, which is strictly anaerobic process, and specifically that methanogens are not feed on the complex organic compounds. They are going to feed on the simple organic compounds only, and it needs the hydrolytic, fermenting, syntropic and acetogenic bacteria also. It is a terminal step of the anaerobic food chain. When the methanogens process there and it forms the methane gas, it is the end point of that anaerobic food chain. Methanogens are less competitive. In case of the methanotrophs, it performs methanotrophy. Methanotrophs are gram-negative aerobic bacteria, feeds on methane, found where an interface between the oxic and anoxic conditions, means where the oxidized and reduced both zones are present. It consumes 80% of the methane produced in the soil. Some species are capable for aerobic and anaerobic oxidation. This is the picture in which we can observe that when organic matter is present in the submerged soil, it gets converted into the methane gas, and afterwards it gets converted into the CO2 if the methanotrophs are present in the soil. Then ebullition process is there and the diffusion process is there. Sometimes the plant also evolve the methane gas from its aerial. There are various mitigation options like methods of planting, rice varieties, nutrient application, water management and the sources of amendment. These different mitigation options we can use for the emission mitigation. Different varieties like Rondo, Jupiter, Francis, CLXL 745. Some nutrients like potassium, nitrogen, sulfur, silicon and iron. And mid-season drying, alternate drying should be there. And the biochar, obviously we cannot stop the addition of the organic matter. We have to add organic matter, but we have to think on it which kind of organic matter we have to add. The biochar is the best option for addition in the soil where the submergence occurs, because it can reduce the methane emission also, and it produces the labile carbon to the plant growth. And SRI method of planting is good for methane emission mitigation. This is the method of emission quantification. This acrylic closed chamber we have to put on that anchor, and for 2 to 3 hours we have to put it during the emission hours, and with the help of the gas chromatography we can estimate the flux, or some biogas analyzers are there in the market, we can go with them. Having look on some case studies, we can conclude it. Application of silicon, potassium ion fertilizer reduced methane emission while increased the rice grain yield. Organic sources like biochar and biofertilizer azolla effectively mitigate the methane emission. Improved methods of rice cultivation, that is SRI method, mitigate the methane emission as compared to the other conventional methods. Alternate flooding and intermittent drainage reduce production and emission. In case of the future perspective, we have to go very far, find out and preparation of the nutrients and forms of the nutrient that able to mitigate methane emission. Obviously, the effective methods of rice straw composting is necessary. The rice cultivation without or minimum submergence, that is very important, because submergence is the key factor for methane emission here. Adoption of improved methods for rice development and selection of rice varieties having greater root parenchyma activity. Isolation, preparation, application of the methanotrophic biofertilizer, collection of methane produced in the rice field and utilization for fuel. Obviously, it is not that much easy, but we have to think on it.